Far beyond Earth, billions of kilometers away, lies Titan, Saturn's largest moon, and the only known moon with a dense atmosphere, even denser than Earth's. Titan is a high-priority target for exploration because it contains most of the key ingredients for life, lacking only liquid water. It has a dense atmosphere, rich organic chemistry, and a surface shaped by liquid hydrocarbons like methane and ethane, the same compounds found in the gas you cook with, as well as a possible subsurface ocean beneath its icy crust. It may also resemble an early Earth, before life first emerged. So what would life on Titan look like? Welcome to Astro via Space. If you enjoy exploring the worlds beyond Earth, consider subscribing for more content like this. In July 2006, the Cassini-Huygens mission discovered vast lakes near Titan's North Pole, confirming that liquid exists on the Moon's surface. The idea was not entirely new. Observations from the Voyager flybys in the early 1980s had hinted that Titan might harbor surface liquids, and data from the Hubble Space Telescope in 1995 provided further evidence. Just a year earlier, Cassini had deployed the Huygens probe, which descended through Titan's atmosphere and landed on the surface. During its 2.5-hour mission, Huygens returned images showing drainage channels carved by flowing liquid. The discovery of stable surface liquids transformed scientific interest in Titan. Originally planned to study Saturn until 2008, Cassini's mission was extended multiple times, ultimately operating until 2017 and allowing scientists to investigate Titan in far greater detail. So, what might life look like in Titan's liquid lakes and seas? If life exists on Titan, it would almost certainly be very different from life on Earth. Our planet's organisms rely on liquid water, moderate temperatures, and abundant sunlight. Titan offers none of these. Instead, its lakes and seas are made of liquid methane and ethane, sitting under a dim, orange sky at temperatures near -179 degrees Celsius. That's more than twice as cold as the lowest temperatures ever recorded on Earth. Any organism living there would need a completely different chemistry to survive. One possibility is that life on Titan could use methane in the same way Earth life uses water. Water is an excellent solvent because it allows complex molecules to move around and interact with one another. Methane is far less effective, but some scientists have suggested that life might still be able to adapt to it. In this scenario, cells could be surrounded by flexible membranes made from nitrogen-containing organic compounds rather than the phospholipid membranes used by life on Earth. Because Titan is so cold, biological processes would likely occur much more slowly than they do here. Reactions that take seconds or minutes on Earth could take days, years, or even longer on Titan. Any living organisms might grow, reproduce, and evolve at a pace that would seem almost frozen from our perspective. A Titan microbe could potentially live for centuries while carrying out only a small number of biological reactions. Energy would also be a major challenge. Titan receives only a small fraction of the sunlight Earth does, around 1,000 times less, roughly comparable to the faint light just after sunset. This is because it orbits nearly 10 times farther from the Sun, and its thick atmosphere blocks about 90% of incoming sunlight, meaning any life would likely need an alternative energy source to survive. One idea is that organisms could obtain energy through chemical reactions involving methane, hydrogen, and acetylene, molecules that are abundant in Titan's atmosphere and on its surface. Rather than photosynthesizing like plants on Earth, life on Titan might function more like certain microbes that survive around deep-sea hydrothermal vents, relying entirely on chemistry instead of sunlight. If such life exists, it would probably be microscopic. Titan's environment is harsh, and there may not be enough available energy to support large complex organisms. Instead of alien plants or animals roaming the shoreline, Titan's lakes may contain tiny microbes drifting through the methane or living along the edges of the lakes where organic compounds accumulate. Of course, this is all speculation. No evidence of life has ever been found on Titan. However, the Moon remains one of the most promising places to search for it because it is the only world besides Earth with stable liquids on its surface and possesses many of the chemical ingredients needed for biology. If life can emerge in an environment as different as Titan's, it would show that biology is far more adaptable than we ever imagined. Though not yet proven directly, Titan is believed to harbor a vast liquid ocean beneath its icy surface, known as a subsurface ocean. Evidence from Cassini's observations suggests that this hidden ocean may consist of salty liquid water, similar in some ways to Earth's oceans, but buried beneath tens of kilometers of ice and completely cut off from sunlight. Unlike Titan's methane lakes on the surface, this environment could potentially be much more familiar to life as we know it. Liquid water is considered one of the most important ingredients for biology, and if Titan's subsurface ocean contains the right chemicals and energy sources, it could provide conditions suitable for microbial life. As mentioned earlier, any Titan life in this hidden ocean might resemble microbes found around deep-sea hydrothermal vents on Earth, relying on chemical reactions rather than sunlight for energy. On our planet, entire ecosystems thrive in total darkness around these vents, where minerals and heat rising from the seafloor provide the energy needed for life. If similar hydrothermal activity exists on Titan, it could create localized regions where water, heat, and nutrients interact. These areas would be among the most promising places for life to develop. Any organisms living there would likely be microscopic and adapted to extreme conditions, but they could potentially survive for millions or even billions of years within the protected ocean beneath the ice. At the moment, no spacecraft has been able to reach this hidden ocean, so its exact properties remain unknown. However, many scientists consider it one of the most promising places in the solar system to search for extraterrestrial life, as it combines liquid water, organic compounds, and possible energy sources, the three key ingredients thought to be necessary for life. So what does all of this tell us? Titan is a world full of contradictions. On the surface it looks frozen and lifeless, locked in deep cold under a dim, orange sky. But at the same time, it has liquid on its surface, complex organic chemistry, and possibly even a hidden ocean beneath its icy crust. We still don't know if anything lives there. But Titan shows us that the ingredients for life aren't unique to Earth. They can exist in places that, at first glance, seem completely uninhabitable. If life does exist on Titan, it probably wouldn't look like anything familiar. It might be microscopic, slow, and completely unlike anything on Earth, existing in methane lakes or deep below the surface in total darkness. And even if Titan turns out to be empty, it still tells us something important. The conditions that could support life might be far more common than we once thought. In the end, Titan isn't just another moon of Saturn. It's a reminder that the solar system is still full of unknowns, and that some of the biggest questions about life are still wide open.